Alright, so we have a standard solution that's prepared for the analysis of this molecule. And we know that a stock solution is first prepared by dissolving 10 milligrams of that molecule in enough water to give a total volume of 500 milliliters. Then we take a 100 microliter portion of this solution and dilute it to a final volume of 100 milliliters. And we want to calculate the molarity of that little portion that we diluted. So that was a lot of words, and I think it's really helpful to visualize what we're doing. So we're starting out with this big stock solution. This is 500 milliliters, or if we want to convert that to liters, that's going to be 0.5. And we know that we take a small portion from that huge stock solution, and that small portion that we take is 100 microliters, which we eventually dilute to a volume of 100 milliliters. And we want to calculate this molarity, right? What's the molarity of that final solution? So we need molarity of our stock solution before we can proceed. And we know that molarity is equal to moles over liters. In this case, we have our volume, which I converted to liters, and we need the moles. So we're given these 10 milligrams that we can convert to find moles. So let's go ahead and start with our 10 milligrams, and we convert that to grams. We know that there's 1,000 milligrams in every 1 gram, and then we convert this to 1 mole of this molecule. And using the periodic table, we get that the molar mass is about 336. And once we multiply all of this out and divide, we get 2.98 times 10 to the negative fifth. But we're not done. We just found the number of moles, but we want the molarity, and we're given our volume that was in milliliters. We converted it to liters, so now we can divide by that 0.5 liters, and this gives us a molarity of 5.95 times 10 to the negative fifth. And what we can recognize is that this is going to be an M1V1 equals M2V2 problem. So in this case, we just found what our M1 is. It's this 5.95 times 10 to the negative fifth. This is our M1. Our V1 is going to be this volume of 100 microliters, but we need to convert it to liters. Our M2 is what we're solving for, and then our V2 is going to be that final volume of 100 milliliters, which we also need to convert into liters. So this is an M1V1 equals M2V2 problem. So let's first convert these 100 microliters into liters. So we know that it's 10 to the 6th microliters for every 1 liter. This is going to give us, I'm just going to move this over. This is going to give us 1 times 10 to the negative 4th liters. And this is equal to our V1. And then our final volume is 100 milliliters. So when we convert that to liters, we know there's 1,000 for every 1 liter. So we got 0.1 liters. And that's equal to our V2. And all we need to solve for is M2. So we're going to plug in everything. And the reason that our molarity, M1, is the same for this smaller portion of the solution is because when we took out these 100 microliters, we didn't do anything to them at first, right? We literally just poured a small bit of this stock solution that had a molarity of this into a smaller little beaker, test tube, whatever. So the molarity stays the same for that first volume. So let's write out our 5.95 times 10 to the negative fifth, and this is multiplied by that V1 volume, so that's 1 times 10 to the negative 4th, and this is equal to M2, which we're solving for, times our V2, which is 0.1 liters. And when we work all this out, we multiply these two, divide by 0.1, we get 5.95 times 10 to the negative 8th M. And that's our final answer.